The measure of heat or energy is not only central to chemistry, but is also central to all the physical sciences and engineering disciplines. In order to study energy, chemists have come up with this equation. Q equals mc delta T. Now let's look at this equation more in depth. Q stands for heat or energy. The units of Q are in joules, J, or calories, cal. M in the equation stands for mass. The mass of the substance is, the units are in grams. Now C is termed the specific heat. The specific heat is a value that represents how much energy it will take for 1 gram of the substance to raise its temperature 1 degree. The units for specific heat are in either joules per gram per degree Celsius or cal per gram per degree Celsius. And finally, delta T is the temperature change. The units of the temperature change are in Celsius. So, to better understand the use of this equation, let's look at the following question. How much energy is needed to increase the temperature of a 50-gram solution of water from 25 degrees Celsius to 90 degrees Celsius? The specific heat of water is 4.184 joules per gram per degree Celsius. Now, let's write out what the question was giving us. The mass is 50 grams. The temperature change, so we're going from 25 degrees to 90, that's a temperature change of 65 degrees Celsius. And the specific heat is 4.184 joules per gram per degree Celsius. We're solving for the heat or the energy, Q. So plugging this into the equation, we're left with 13,598 joules. Now, this is not the correct number of significant figures. So looking at the numbers that we plugged into the equation, 65, having 2 significant digits, is the least number of significant figures in the equation. So our final answer needs to have just 2 significant figures, or 14,000 joules or 14 kilojoules. Now, for practice, try this equation. Also know that the density of water is 1 gram per milliliter. All right, how many degrees will the temperature increase if 8,100 joules of energy is added to 150 milliliters of water? The specific heat of water is 4.184 joules per gram per degree Celsius. Now, the mass of the water, since the density of water is 1 gram per mil, so 150 milliliters of water is actually 150 grams of water, so the mass is 150 grams. We're solving for delta T. The specific heat is 4.184 joules per gram per degree Celsius. Q is 8,100 joules. So, plugging this into the equation, we solve for delta T. We get a value of 12.90631 degrees Celsius. However, looking at the numbers that we plugged into the equation, the least number of significant figures is 8,100 and 150, which only has 2 significant figures. So our final answer needs to only have 2 significant figures. So the final answer is just 13 degrees Celsius.